Dear students, welcome back. In the previous session we have discussed about the semiconductors. Now in this session we are going to discuss about the transistor. Transistors are the electrical device which utilize a combination of P and N type semiconductor materials. Simply we can say it is a sandwich of P and N type of semiconductor materials. It can be NPN, it can be NPN, yes, it can be NPN or PNP. Okay, here in this diagram you can see NP type, NPN type of transistor. Okay, in NPN transistor, so this is an NPN transistor. It consists of two thick layers of N-type semiconductors. So you can see the thick layers of N-type conductors, okay, and one thin layer of P-type conductors. Okay, so the semiconductor has three parts. One is the emitter, base and collector. Okay, so normally one of the N type at the left, so on the left side it is called as emitter, the other one is at the right is called as collector, and the central P type is base. Okay, on contact being made between the materials, say which means NPN semiconductors, in this case the potential difference develops at their junctions. So at their junctions the potential difference develops. The emitter and the collector being positive relative to the base. So when the emitter and the collector being positive in relative to the base, when the device is connected to a source of EMF, okay, so with an emitter negative charge, and collector with the positive charge. Okay, so no current flows unless the EMF exceeds the critical value. Okay, so though it may connected to the source, the electrons will not flow until it reaches to or it exceeds the critical value. Okay, so for that reason the electrons are unable to pass from negative P type to the positive N type semiconductor. So the electrons will unable to move from N type to P type semiconductor. So it cannot cross the base as well as the collector junction. So then what is the use of this kind of transistor then? So then they have connected a second source of EMF which is connected to base now. So now another source of EMF is connected to the base and the emitter, so base and the emitter. So the electrons can pass from negative N type to positive P type of semiconductor now. So the current flows across the base. So once the electrons enter into this P type, when there is a sufficient amount of electrons are present, then this N type is on the collector side which is connected to the positive charge, then these electrons will flow into the collector. Okay, in the circuit there is a thick layer of N type semiconductor and a thin layer of P type semiconductor. So the current consists largely of the movement of electrons and the electrons from the emitter soon pass into the base because it is thin. Okay, the base has now an adequate supply of electrons, and as it is very thin, these come close to the base. These come close to the base. Okay, base and collector junction and are attracted into the collector. So what I have explained, so that is the thing happening to replace those that had migrated into the base. Okay, so this reduces the barrier effect across the base collector junction and current flows across the transistor. Thus, a current fed into the base renders the transistor capable of conducting current, and small variations in this base current causes greater variations of current flowing across the transistor. So, in this respect, the current fed into the base of the transistor has an effect comparable to that of positive charge applied to the grid of a triode wall. So this base acts as a grid which is present in the triode wall. If you see the uses of transistors are used in preference to the walls. Okay, so actually in the early periods of the development of walls, there is no semiconductors at that time, so they are using only walls at that time. So after the semiconductors came into field, then they are preferring in the place of walls. Okay, transistors are used in preference to the walls in most modern electrical equipment because they are durable and have a long life, which also consume less power and need no heating of device. Here no heating is taking place, whereas in the walls heating of the filament is required to release the electrons, but that one is not required here. Okay, as the power output is limited, they are very much suitable for the use in the production of low frequency currents, but it is failed to produce high frequency currents. So these transistors are mainly used in the production of low frequency currents. So the main function of this transistor is it is used in the production of low frequency currents, but these transistors are failed to produce high frequency currents, and these transistors are used in the preference to the walls in the most of the modern electrical equipment because they are durable and have a long life and consume less power and need no heating of the device. Okay, so this is all about the transistor. In the next session we are going to discuss about the rectifiers. Thank you.